Hey guys, and welcome to the school station. Today's video I'm going to be talking about gravitational potential energy. This is from the AQA GCSE Physics 9-1 paper from the unit Energy and Energy Resources. In my previous videos, I've talked about energy transfers and the 10 main types of energy. However, there is some specific energy that actually have its own formula and you'll have to calculate it during the exam. Gravitational potential energy is one that many students struggle in, and since there is a whole formula for it, today I'm going to be telling you guys about gravitational potential energy. So before we actually get on with it, we actually have to know what is gravitational potential energy. So gravitational potential energy is one of the many types of energy because there are 10 types of energy, but gravitational potential energy is actually an energy that is talking about gravity and its store inside an object. So gravitational potential energy can be written in many textbooks as GPE because that's the short form of saying it, and every single object has gravitational potential stored inside it. And when you're lifting something up, you actually are increasing the gravitational potential energy store. So now we're going to be talking about some rules of GPE. So some rules of GPE is that the GPE store of an object increases when it moves up and decreases when it moves down. For example, if I have a notebook and I'm lifting it up, I'm actually increasing the store of the object, the GPE store of the object. And when I'm taking the book down, back into the table, I'm actually decreasing the GPE store. The GPE store of an object increases when it is lifted up because work is done on it to overcome the gravitational force. So basically, when you are lifting it up, you're actually using your energy, your chemical energy, which transfers into gravitational potential energy. Because when you're lifting it up, you are actually putting work on it to actually lift the notebook up. And that is actually why the gravitational energy is actually increasing. And last of all, the gravitational field strength of the surface of the moon is less than on the Earth. So every single planet has its own gravitational field strength. In the Earth, it is 10 newtons per kg, but in the moon, it's going to be less. So therefore, it's going to be changing all the time. So now that we know about GPE and what it is and also some rules about it, now we're going to be actually going on to the formula about how to calculate GPE. So the formula for GPE is mg is equals to mgh. So you just have to remember GPE is equals to mgh. That is how easy it is. Mass, M stands for mass, which actually is measured in kg. And I know that sometimes when we go to the doctors, we say that what is my weight, and they tell you in kg, but in scientific purposes, weight is actually measured in newtons and mass is actually measured in kg. So when you're known, let's say, as 50 kg, your mass is actually what it is. It's not your weight that is 50 kg, it's your mass that is 50 kg. And your mass never changes. So M is equals to mass, which is measured in kg, and then G is equals to gravitational field strength, which is actually measured in newtons per kg or meters per second squared. So it really depends on the question. And last of all, we have h, which is equals to height, which obviously is measured in meters. So that's what you have to remember. And again, if we have this triangle of GPE, what we have to do is that, for example, if we're asked one day to find the mass, and we have our GPE, our gravitational field strength, and our height, then we can just cover up the mass and we can do GPE divided by gravitational field strength times height. So we can basically just cover up the thing that we're trying to find and we can use the formula. And something else that I also want to say before continuing with the video is that usually in most questions they may actually not tell you the gravitational field strength, because you have to already know that if they don't tell you what planet it is, then they're assuming that it is on the Earth. So the gravitational field strength in Earth is always 10 newtons per kg. So therefore always make sure that you know that sometimes they're not going to tell you the gravitational field strength because they're assuming it's on Earth. So now that we know about the GPE formula, now we're going to actually go on to an example. So a normal or typical exam style question you may get is calculate change in GPE when a 1000 kg airplane takes off up to a height of 500 meters. So first of all, we have to look at what we're trying to find. So this question, sometimes not in all questions, they're just going to tell you simply to calculate GPE. In other questions, they will try to make you think about it, what you were trying to find. But luckily in this example, it already tells us what we're trying to find. But over here, we're trying to find the change in GPE when a 1000 kg airplane, so 1000 over here is the mass, takes off up to a height of 500 meters, and 500 meters is obviously the height. And again, as I said earlier, the gravitational field strength is not mentioned in this question because they want you to assume that it is on Earth, and you have to memorize the gravitational field strength in Earth is 10 newtons per kg. So if I was to just work this out, it would be E with a small p, and that's how you represent gravitational potential energy, is equals to mgh. So always write down the formula because that could give you an extra mark, and then equals to 1000 times 10 times 500. So I just substituted all the numbers from the letters, and that is equals to 5 million joules. So that's going to be the answer for the change in GPE, and that should basically be your answer. It's really that simple. So I hope you guys have understood this example and also the formula. And now I'm going to be actually going on to the next example. And in this example, they're actually asking you that a student of 30 kg climbs on a platform that's height of 1.2 meters higher than the floor. Calculate the increase in gravitational potential energy stored. So I want you to pause this video and try this. Remember to use the formula, and remember to also know that the gravitational field strength is not always going to be mentioned. So pause this video and try this question yourself before continuing with the rest of the video. Alright guys, so I hope you guys have tried it out, and now I'm going to be going on with the answer. So here is the answer. So again, what I did was I wrote down the formula first of all, because again asking you for the gravitational potential energy store. So I did 30 times 10 times 1.2, where 30 is 30 kg, which is the mass, 10 is 10 newtons per kg, which is obviously the gravitational field strength, and 1.2 meters is the height. So I did 30 times 10 times 1.2, which is equals to 360 joules, and that's going to be your answer. So I hope you guys have learnt a lot about gravitational potential energy, and just to kind of review about what we have learnt today in this lesson, we have learnt what GPE stands for. GPE stands for gravitational potential energy. We also have learnt the formula for GPE, which is mgh, E with a small p is equals to mgh, where m stands for mass, g stands for gravitational field strength, and h stands for height. And we've also learned how to solve questions with GPE. Obviously, the best thing you can do is to always make sure you're practicing questions. So even after this video, try to practice many questions involving GPE. So I hope you guys have enjoyed this video. Give this video a thumbs up if you enjoyed it, subscribe down below, and also make sure to stay tuned for more free science and maths lessons from the school station. Bye guys!